Welcome back, Focus Learners. Today, we're diving into a brand new explainer where we are taking on a rather unique role, the geneticist. But listen, instead of sequencing human DNA in a lab, we are going to engineer the absolute perfect, foolproof Cambridge Mathematics A-star answer. Whether you're building your mathematical foundation in the 0580 syllabus, stretching your abilities in the 0606 or 4037 add math, looking at 4024 or 4040, or taking on the absolute beast itself, the 9709 AS and A-level mechanics paper, you already know one thing for sure. Identifying forces and drawing accurate force diagrams is the absolute bedrock of the entire syllabus. But here's the secret. Knowing the math just isn't enough anymore. We need to decode the examiner's playbook. Picture this. You've got a real Cambridge past paper question in front of you. On one hand, we have a student, let's call him Alex. Alex overloads his answer with raw mathematical facts, throwing down every equation he knows but with absolutely zero analysis. On the other hand, we have Sam. Sam rushes through the paper, completely misses the specific command word requirements, and ends up solving a problem the examiner didn't even ask for. Both get their papers back covered in red pun marks. Today, I'm going to show you exactly how to structure your answers to avoid their mistakes, demonstrating the connected, conceptual understanding the exam board strictly demands. Evidence plus analysis equals an A-star. It really is that simple when you understand the mechanics behind it. Okay, let's dive into exactly how we're going to transform those red pen marks into green check marks. We have 5 crucial steps to cover today to demystify what examiners actually want to see from your mechanics force diagrams. First, we'll look at the core principles of Cambridge mechanics, and I'll introduce you to the Peel framework tailored specifically for math. Second, we'll walk through the problem-solving sequence. Third, we'll decode method marks and methodology. Fourth, we'll look at the top 3 examiner warnings, straight from the principal examiner reports. And finally, we will wrap it all up with the evaluation framework. Let's kick things off with Section 1, Mechanics Mastery and Core Principles. This is where we establish the absolute necessity of connected, conceptual understanding in your exams. We're going to look at the specific assessment objectives for mathematics and see how top-tier students structure their thoughts before their pen even touches the paper. This is where we introduce the Peel framework, point, evidence, explanation, link, and apply it directly to mechanics. So I really want you to think about this question. Why do students lose crucial mechanics marks? Why is it that evaluating evidence and drawing conclusions from a seemingly simple force diagram is so incredibly hard under the intense pressure of exam conditions? Think about it for a second. You already know how to resolve a vector. You know Newton's laws inside and out. So where is the disconnect happening? Well, it almost always happens right at that high-stakes transition from a B grade to an A-star. It is the massive jump from just doing the math to systematically proving the physics. Think back to our student Sam, rushing and missing command words. If a question says, show that the system is in equilibrium, simply calculating a final value isn't enough. You have to prove the journey. Just look at this quote directly from a Cambridge senior examiner. They state clearly, the difference between a B and an A-star in mathematics often comes down to how well you understand mechanics, forces, and equilibrium. What this examiner is practically shouting at us is that your ultimate success is entirely about mastering the process. It is not just about knowing raw mathematical facts or memorizing a list of kinematic formulas. It is about how you conceptually handle the invisible forces on that page and translate them into a logical, undeniable argument. So, the absolutely crucial point here is understanding the stark difference between superficial breadth and analytical depth. A student who gets a B often relies on superficial breadth. This is our student Alex. Alex throws every single equation at the paper. F equals ma, friction equals mu times r, Suvat equations, just hoping something sticks. It's a vague scattergun approach. But the Cambridge syllabus strictly demands analytical depth. Top-performing students exhibit a connected, conceptual understanding that they can transfer to totally unfamiliar contexts. When they look at a force diagram, they use logical, structured reasoning. They use the PEL framework. They make a point about the forces, provide mathematical evidence, explain the equilibrium, and link it back to the command word. They don't guess, they systematically prove. Which brings us beautifully to Section 2, the problem-solving sequence. This is the actual procedural framework required to systematically solve complex force and equilibrium problems from past papers. Now, before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Trust me, you are going to want to have notifications on for the strategies we're about to unpack. Let's move to the sequence and see exactly how this builds. This is the standardized deconstruct, solve, evaluate methodology. Imagine a 60-second visual countdown timer on your desk. Challenge yourself. Can you extract the core trend from a complex mechanics paragraph in that time? Step 1. Identify key elements. Break it into logical bits. Where's the particle? What's the mass? Step 2. Apply relevant principles. Are we using Newton's first law or second law? Step 3. Execute your analysis with crystal clear working. Step 4. Verify your results. Does a negative tension make physical sense? Hint, no it doesn't. And step 5. Present your final answer clearly. If you skip a single one of these steps, you are literally leaving marks on the table.
And speaking of presenting clearly, you must adhere to strict presentation conventions. Let's play a quick game of Find the Flaw. If I show you a sample mechanics paragraph where a student writes, "The force goes up," where is the flaw? The flaw is terminology. Examiners look for the correct terminology like normal reaction force or tension. They want proper headings, appropriate formats, and incredibly clear annotation on your force diagrams. If you draw a diagram, clear annotations instantly secure marks. You need to show the examiner exactly where the tension acts, away from the particle, where the friction opposes motion, and how the angles are resolved relative to the plane.
Let's shift gears and look at Section 3, Method Marks and Methodology. I cannot stress enough how vital this section is. This is the ultimate safety net in Cambridge mathematics exams, and it's where we see the biggest transformation from red pen mistakes to green check marks.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Seriously, do it now, because this next strategy is a total game changer.
Now, what's really fascinating about this slide is the method marks strategy itself. These are marks awarded specifically for demonstrating the correct problem-solving process, regardless of your final numerical answer. Let that sink in for a moment. You could get the final number completely wrong and still walk away with the majority of the marks. Practical application in mechanics develops professional problem-solving skills. The examiner wants to see you apply correct formats. They're actively looking to reward your analytical process. If your logic is flawless, if your force resolution equations are set up perfectly, but you accidentally drop a negative sign at the very end on your calculator, method marks are exactly what keep you in the running for that A-star.
This brings us to a massive examiner alert straight from the source, and it's the golden rule of mechanics. Students lose marks by not showing working. Even if your final answer is wrong, method marks can save you. An undocumented force diagram is a massive, unnecessary risk. Imagine a 30-second speed writing challenge. In 30 seconds, you need to write one perfect peel paragraph defining your forces. If you do all the vector resolution in your head or punch it straight into your calculator without writing down the intermediate horizontal and vertical equilibrium equations, you are flying without a parachute. Show you're working every single time.
Moving into Section 4, the top 3 examiner warnings. We are shifting focus to the highest stakes part of this explainer. These are the specific pitfalls that absolutely cost students their target grades, straight from the people grading your papers. We dug deep into the Cambridge Principal Examiner reports, specifically for the Mechanics 9709 paper. And here is the hard data on the top mistakes. Warning number 1, vague answers lacking specific details. Don't just write F. Is it driving force, friction, tension? Be specific. Warning number 2, forgetting format and presentation checks. A messy diagram with unlabeled arrows is a fast track to 0 marks. And warning number 3, answers not specific to the given context. If the question involves a particle on a rough inclined plane, your friction forces need to reflect that specific reality, using F equals mu r, not just some generic formula. You have to contrast these common mistakes with the highly specific, context-driven answers examiners expect.
Finally, we arrive at Section 5, the evaluation framework. This is the final piece of the A-star puzzle. This is where we present the complete mathematics answering system, satisfying the higher-order assessment objectives through robust, undeniable evaluation. And this brilliantly illustrates how top students construct their final answers. This is your cheat sheet recap. The framework for critical analysis requires layers: descriptive, analytical, and evaluative. When a problem asks you to evaluate a system, you use comparative analysis. You identify similarities,
You contrast key differences, but most importantly, you provide evidence. You support every claim with hard data pulled directly from your force diagram. And finally, you draw conclusions to judge relative importance. Remember the 3 rules that guarantee top marks. Number 1, command word decoding. Number 2, Peel framework application. And number 3, a time management matrix to ensure you never rush like Sam did. That is how you engineer an A-star.
Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. So, I leave you with this. How will you apply the Deconstruct, Solve, Evaluate framework to your next mechanics past paper? Get out there and start practicing.